There's really two approaches on this specific problem. You could use some algebra and expand out this expression, FOIL it out into 4 terms, and then use the power rule on each term. Or you could use the product rule and take the derivative of the first function, hold the second function, plus the derivative of the second function, hold the first function. I'm going to use the product rule because it might be easier in the short term to FOIL it all out, but on some of the other examples you can see that here it's going to take me a lot longer to take this to the third and then this to the fourth and then multiply them. I have a lot more factors to deal with. So let's look at the example here using the product rule. And the product rule is if you take the derivative of a product of 2 functions, I'm going to write that as f of x times g of x. Take the derivative of the first function, hold the second function, plus the derivative of the second function, hold the first function. Right? So here, I'm going to take the derivative of my yellow function. So that's going to be 8 times 2x to the first power. Right? Plus 0. I'll go ahead and write it just so it's clear, and I'll clean it up later. Hold the second function. Go ahead and write that in blue just to let you know I'm holding that. Plus the derivative of the second function, which would be 4 plus 1/2 x to the minus 1/2. Hold the first function, right? So the derivative of the first function, hold the second one, plus the derivative of the second one, hold the first one. And a lot of times, anytime I have the square root of x, I'll write that as x to the 1/2. Just to clarify, the derivative of x to the 1/2 is 1/2 x to the minus 1/2. Sometimes you'll see it written as 1/2 the square root of x, but 1/2 x to the minus 1/2 is completely acceptable. So cleaning this up a little bit, I have 16x times 4x plus the square root of x plus 4 plus 1/2 x to the minus 1/2 times the quantity 8x squared plus 7. This would be how I would write my final answer there. Leave it in this form. This example is doing very similar things, except now we're going to also look at the chain rule within the product rule. So if you recall, the chain rule is the derivative of a function that's a composition, so say something like f of g of x, would be the derivative of the outside evaluated at the inside times the derivative of the inside. So this is something cubed. The derivative of something cubed would be 3 that something squared. So the derivative of the outside evaluated at the inside, don't change the inside, times, then you take the derivative of the inside. In this case, it's just 4. Right? So all of this is the derivative of the yellow. So I have to still hold the second function, because my format is the derivative of the first function, hold the second one, plus the derivative of the second. So if I take the derivative of the second function, I'm going to have 4, 1 minus x to the 5th cubed times minus 5x to the 4th. So be careful with that negative. So that's the derivative of the blue function, derivative of the outside evaluated at the inside times the derivative of the inside, but then I have to hold the first function. So 4x minus 1 cubed. There's a lot going on here. You can actually simplify it a little bit further by pulling out some like terms. However, my math lab should accept this completely. You could maybe combine some things and pull out some things, but you don't have to. I'll go ahead and just kind of show you the steps of pulling out things, but keep in mind you don't need to. I have this 4x minus 1 and this 4x minus 1. I have 3 factors and 2 factors, so I can pull out a 4x minus 1 squared out of both terms. I can pull out, what else do I have? I have a 4 and a 4, so I can pull out a 4. I have a 1 minus x to the 5th and a 1 minus x to the 5th. I have a maximum of, or I have 4 here and 3 here, so I can pull out 1 minus x to the 5th cubed. I think that's all I have in common. So you can see out of my first term, I pulled out a 4. I pulled out 2 4x minus 1, or 4x minus 1 squared, and I pulled out 3 of the factors of the 1 minus x to the 5th. So I'm left with a 3 and 1 of the factors of 1 minus x to the 5th. Plus, my second term, I pulled out a 4. I pulled out 1 minus x to the 5th cubed. I pulled out, or in this case, I'm left with a minus 5x to the 4th and 1 factor of the 4x minus 1. So you might see this on Help Me Solve It or View an Example. So that's it simplified. Here's a similar example, but you have to note that this is a little easier than the one we did before because we're differentiating it term by term. So the derivative of the first function, or the derivative of the first term, right, is going to be 4, 2 plus x to the 5th cubed times x to the 5th, or sorry, 5x to the 4th. Right? So I take the derivative of the outside, evaluate it at the inside, times the derivative of the inside. Minus 5, 4 plus x cubed to the 4th power, times the derivative of the inside, in this case, is 3x squared. So cleaning it up, simplifying it, 5 times 4 is 20, x to the 4th times 2 plus x to the 5th all to the 3rd power minus 15x squared, 4 plus x cubed to the 4th power. You could simplify it a little bit further by pulling out a 5x squared, but it's not super beneficial in this case. So a function like this is a little easier to differentiate than a function that is being multiplied, because when it's being multiplied, take the derivative of the first function, hold the second one, plus the derivative of the second one, hold the first one. It's a little bit larger versus derivative of the first term minus the derivative of the second term. Hopefully this cleared up any questions you have over them. If you have any more, please let me know.